Good morning, students. Today we discuss the regression analysis or simply regression. Regression is basically represents the average relationship between two variables. So, another meaning of regression is the prediction. If the value of the one variable is given, we want to predict the value of the another variable. Then to predict the value of another variable, we use the concept of regression. So, regression is basically the average relationship between two or more than two variables, or regression means estimation or prediction of one variable on the basis of another variables. So, regression, if we study the regression, there are many types of a regression. First type is simple regression. Simple regression means if there are only two variables in the study, then the regression is known as a simple regression. Now, multiple regression means if more than two variables are involved in a study, then the regression is known as multiple regression. And next is partial regression. Partial regression means if more than two variables are studied, and to study the relationship between two variables, we assumed third variable as a constant. So then this type of regression is known as partial regression. Next type is linear regression. If the change in y, let us suppose we have a two variables x and y, if the change in y and x is in equal proportion, then regression is linear regression, otherwise non-linear regression. So, regression basically defines the average relationship between two or more than two variables. Now we discuss the different types of regression line. So, firstly, we discuss the meaning of regression line. A regression is represented by a line, and that line is known as a regression line. So, to represent a regression, a line is found, and that line is known as a regression line. So, to present a line, we require two variables. One is a dependent variable and another is independent variable. So, if y is our dependent variable and x is our independent variable, then the regression line is y on x. And on the other hand, if x is dependent variable and y is our independent variable, then the regression line is line x on y. So, we have basically two lines. First is a regression line y on x, and second is regression line x on y. In regression line y on x, in the regression line y on x, y is dependent and x is independent variable, and in a regression line x on y, x is dependent and y is independent variable. So, if we choose the line y on x, that means we want to predict the value of y, that value depends upon the value of x. And if we have the line x on y, that means we want to estimate the value of x, that value of x is depend upon the value of y. Now, first we discuss the least square method to find a regression line. So, the regression line by least square method. Firstly, we write the regression equation of y on x. Regression equation of y on x. So, regression equation of y on x is y equals to a plus bx. And the normal equations are, So because here there are two constants a and b. To find the values of a and b, we required the two normal equations. So to write the normal equation for this equation, firstly if we take a summation y equals to, because there is a no variable here, so this become n into a plus b into summation x. And second normal equation is summation xy equals to a into summation x plus b into summation x square. From the given data, we can put the value of n, summation x, summation y, summation xy, summation x square. After substituting all these values, from these two equations, we find the value of a and b. So after finding the values of a and b, we substitute in this equation, that is our required equation of y on x. Now our second equation is regression equation of x on y. So the regression equation x on y is x equals to c plus dy. Again here there are two constants c and d. To find the value of c and d, we required a two normal equations. So the first normal equation is summation x equals to nc plus d into summation y, and second normal equation is summation yx equals to c into summation y plus d into summation y square. Again in these two equations, we put the value of summation x, n, summation y, summation xy, summation y square. So after substituting all these values and simplification, we find the value of c and d from this. So now we discuss the numerical based upon this method. From the following data, find two regression equation. So we have to find the regression equation of y on x as well as the regression equation of x on y. Values of x are 2, 4, 6, 8, 10. Values of y are 12, 16, 14, 12 and 16. So we find x square, xy, y square, then we find the sum of all these. Now firstly we suppose the regression equation of y on x is y equals to a plus b x, where a and b are given by. So value of a and b are found with the help of these two equations. Summation y equals to na plus b summation x plus summation yx equals to a summation x plus b summation x square. After substituting all these values, after putting the value of summation x square, we get 70 equals to 5a plus 30b, 428 equals to 30a and 220b. So now you can solve these two equations and find the values of a and b. After solving these two equations, you can get the value of a is 12.8 and value of b is 0.8. So our required regression equation y on x is y equals to 12.8 plus 0.2 into x, because the value of a is 12.8 and value of b is 0.2. Now this is our regression equation of y on x. Now we find second regression equation. Second regression equation is regression equation of x on y, that is x equals to c plus dy, where the value of c and d are given by using these two normal equations. Summation x equals to nc plus d summation y, summation xy equals to c summation y plus d summation y square. Again here we substitute the value of summation x, summation y, summation xy, summation y square. And after putting all these values, after simplification, we get the value of c is value of c is -1 and value of d is 0.5. So after substituting the value of c and d here, we get our required regression equation. Now we discuss next regression coefficient and its different properties. The slope of regression line y on x is called the regression coefficient of y on x. So if we have a regression line y on x and if we find the slope of that regression line, that slope is known as regression coefficient of y on x. Similarly, if we have the regression line x on y, if we have the regression line x on y, then the slope of regression line x on y is the coefficient of regression x on y. Now that formula is used to find the regression coefficient of y on x, covariance between xy over variance of x, that is equals to sigma xy over sigma x square. Then this is equals to r sigma y over sigma x. This is the regression coefficient of y on x. So therefore here we can write byx, and this represents the regression coefficient of x on y, covariance between xy over variance of y, sigma xy over sigma y or sigma x over sigma y. Now we discuss some properties of the regression coefficient. Now correlation coefficient is geometric mean between the regression coefficient. That means our r equals to plus minus under root byx into bxy. Our correlation coefficient is represented by r. So r equals to plus minus under the root byx into bxy. Second property is that if one of the regression coefficient is greater than the unity, then other must be less than unity. Third property, both the regression coefficients have the same sign. Both the regression coefficients have a same sign. Next property, correlation coefficient will have the same sign as that of a regression coefficient. So the correlation coefficient, if the regression coefficients have a sign positive, then the correlation coefficient also have a positive sign. If they have a negative sign, then correlation coefficient is also have a negative sign. The product of two regression coefficient is always less than or equal to unity. Next is average of regression coefficient is greater than the correlation coefficients. Next is regression coefficients are independent of change of origin. So the regression coefficients are independent of change of origin. Regression coefficients are not independent of change of scale. That means if we change the scale, then this affect our regression coefficients. Now firstly we discuss the direct method to find the regression equation. The regression equation of y on x is given by y minus y bar equals to byx x minus x bar. The value of byx is given by summation x minus x bar y minus y bar over summation x minus x bar square, and byx is either given by n into summation xy minus summation x summation y over n into summation x square minus summation x whole square. So here x is our x series, y represent a y series, y bar means mean of a y series, x bar means mean of a x series. So from these two formulas we can choose either a first formula or second formula to find a regression coefficient. After finding the regression coefficient, we substitute here regression coefficient, mean of y series, mean of x series, and we obtain our required regression equation. Then our second, the regression equation of x on y is given by x minus x bar equals to bxy y minus y bar. Here the value of bxy is given by summation x minus x bar y minus y bar over summation y minus y bar whole square, or bxy equals to n into summation xy minus summation x summation y over n into summation y square minus summation y whole square. So now we discuss the numerical example. The following data relates to the scores obtained by a salesman of a company in an intelligence test and their weekly sales in 1,000. Obtain the regression equation of sale on an intelligence test scores of a salesman, and if the intelligence test scores of a salesman is 65, what would be his expected weekly sales? So salesmen are given A, B, C, D up to so on. Intelligence test score is represented by X, weekly sale is represented by Y. So we use any of the method to find. Firstly, we find mean of X series, summation X, that is equals to 540 over 960, summation Y 450 over 950, then we find x minus x bar, y minus y bar, x minus x bar square, y minus y bar square. So that is equals to, let the regression equation of y on x is y minus y bar equals to b by x, x minus x bar. Here we use this formula, we substitute all these values and we find the value is 0.75. So our regression equation is y minus 50, 0.75, x minus 60. After simplification, we get equation is y equals to 0.75 into x plus 5. Now, if the test scores are 65, then the weekly sales is obtained by, here we put the value of x is 65, that is equals to 53.7. Next is a shortcut method to find a regression coefficient. By shortcut method, regression coefficient is given by byx, n into summation dx dy minus summation dx summation dy, n into summation dx square minus summation dx whole square. So where dx equals to x minus a, dy equals to y minus b. As we know, a is assumed mean from a x series, b is assumed mean from a y series, and bxy equals to n into summation dx dy minus summation dx summation dy, n into summation dy square minus summation dy whole square. So if the means are not obtained easily, then we use a shortcut method to obtain the regression coefficient, because by shortcut method we not use the exact mean, we used a assumed mean. So student, as we discuss in this example, given below the following information, mean of x series is 65, mean of y series is 67, standard deviation of x series is 2.5, standard deviation of y series is 3.5. Coefficient of correlation is 0.8. Find two regression equation associated with the web data. To find a two regression equation, we require the two regression coefficients. First, we suppose the line regression equation of y on x, y minus y bar equals to b by x, x minus x bar, where the value of b by x is equals to r sigma y over sigma x. So we substitute all these values because these values are given. Sigma y is 3.5, sigma x is 2.5 and r is given as 0.8. After simplification, we get this is equals to 0.57. So after finding that, we put here. So our regression equation y on x is y minus 65 equals to 0.57, x minus 65. After simplification, we get this is our regression equation of y on x. Now we suppose the regression equation of x on y, x minus x bar bxy, y minus y bar, where bxy is given by r sigma x over sigma y. Again we substitute the given values and this is our regression equation of x on y.